Welcome back to another lecture. So we are trying to predict whether the reaction is going to move on forward or not, and without technically using any pKa. And we are following our U. A stands for atom, R resonance, I induction, and O it will be orbital. Okay. So in this case, we have 4 molecules, and the difference between them is like the neighbor carbon. Okay, this one, it has 3 hydrogen, and then we started replacing the hydrogen by chlorine until we got all hydrogen replaced by 3 chlorines. Question is asking which one it has the highest acidity. Okay, only difference between them is the induction effect. And this carbon, it has more chlorine attached to it, so I'm going to say it will apply more technically cooling effect or induction effect, and it will make carbon thirsty of electron, and carbon is going to try to get electron from oxygen, and oxygen will get it from hydrogen. So the answer is going to be this. So number 4, it will be the strongest acid. Why? Because it has more electronegative element attached to it, and the conjugate base, it will be more stable. Okay, now let's follow the last letter, which is orbital. Okay, now should I be worried or should I care about hybridization of the atoms that's technically is dealing with the negative charge? And why should I bother to know the hybridization for it? Okay, so we said when you're comparing 2 elements that they got negative charge, the one with the bigger size, it can easier accommodate the negative charge. Because it can easier accommodate the negative charge, it will be more stable, so it will give you a stronger acid. Now, what will happen if we are dealing with the same sizes, almost same sizes, carbon versus, for example, oxygen? In that case, we say the one that is more electronegative, the one that's more. What if them are carbon? Okay, and I want to compare them. In that case, go with hybridization. The one that has more S character, it will have higher electronegativity. Okay, so the one that has more S character, it will have higher electronegativity. So I'm going to say this one is 50% S character, and here 1/3, so it will be 33% S character, and okay, 1 out of 4, so it will be 25% S character. The more S character we have, the higher electronegativity. That means more stabilization. So we're going to say this: electronegativity of Sp is higher than electronegativity of Sp2, higher than electronegativity of Sp3. Okay, if you want to trend them, if you want to order them based on acidity, so I'm going to say a carbon that is involved in a triple bond is more acidic because it has Sp hybridization stronger than this. This is going to be Sp2, and the last one, it will be carbon that it has the 3 hydrogens attached to it. Okay, this is going to be Sp3. So the most acidic acid, the most acidic hydrogen in this case is going to be the Sp. Okay, now I have 2 carbons, one carbon that it has Sp2 hybridization, and second carbon it has Sp1 hybridization. Okay, 4 carbon, if it's octet and you want to figure what's the hybridization, there is no positive or negative charge for it, you can use this formula: Sp3 minus N, and what's the N? N is number of pi bonds. Okay, N is number of pi bonds. Okay, so I'm gonna say Sp3 minus how many pi bonds I have? I have 2 of them, so it will be equal to Sp. Okay, in this case, number of pi bonds is going to be equal to 1, so it will be Sp3 minus 1, it will be Sp2. Okay, now let's take hydrogen from them. If we take hydrogen from them, okay, we get on the left side, we get a carbon that it has Sp2 hybridization, and this one, if we take the electron of hydrogen from the one on the right side, we get the carbon with Sp hybridization. Which one is more stable? The Sp. Why is more stable? The higher S character, or the higher S character you have, the closer you will be to the nucleus. Remember, you are dealing with electrons. Electrons are outside of the nucleus. If they get close to the nucleus, you will have more attraction force between the protons and the electrons. So the higher S character you are dealing with, the closer those 2 electrons will be to the nucleus. And if they're closer, system will be stable. More stable means less reactive, okay? Less reactive. So Sp is more stable means less reactive, okay? Sp is more stable means less reactive. So I'm going to say if you take H from Sp hybridization, okay, you will get more stable conjugate base, And because the conjugate base, it will be more stable. So I'm going to say that H, it will be more acidic. I'm talking about this H. That H is more acidic. So which one of this is more acidic? The one that has sp hybridization versus sp2. So sp is more acidic than sp2. Okay. We have carbon. Okay. And we have 3 carbons, and the only difference between them is the hybridization. So let me, okay. I think I need more space to work on this equation. And the only difference between them, again, is the hybridization. So we have sp3 here. This one is sp2, and that is sp. So carbon that attached to hydrogen, and hybridization of carbon is sp, and carbon attached to hydrogen, hybridization is sp2, carbon attached to hydrogen, and the hybridization is sp3. Okay, which one is more acidic? Okay, this is going to be the trend for them. Okay, so let's call this one. Call this 1, this is 2, and that one 3. Okay, number 1 is more acidic than number 2 than number 3. Okay, and how about this example? Okay, this example is going to be for you guys. Okay, so I wanted to give it a thought and pause the video here and try to order them based on their acidity. Okay, great job. Okay, I hope you got it correct. And here's the answer for it. So we have nitrogens. Okay. And the difference between them is technically hybridization of nitrogen. Okay, so the first one, you have a nitrogen that's involved in triple bond. Okay, and whatever attached to it. Okay, so I have sigma and sigma. I have 2 sigmas. Because I have 2 sigma, the hybridization is going to be S1, P1. So we got 2 sigma. Hybridization, it will be SP1. Okay, next, we have nitrogen attached to 2 hydrogens and then attached to 2 carbons. Okay, those are carbons. And of course, you got a ring here. Okay, and each corner represents a carbon. So I have 4 sigmas. Okay, I have 4 sigmas here. So we got 4 sigma. What's going to be the hybridization? 1 from S, 3 from P. Hybridization is going to be sp3. Of course, you got 4 orbitals. Like the previous one, also you got 2 orbitals. I try not to write them. Okay, I'm just trying to save some time and space. Okay, and the last one, we have nitrogen, okay, involved in double bond. Okay, so I got the sigma bond here, and another sigma bond. Okay, so we got 3 sigma bonds. That means we need 1 from S and 2 from P. So the hybridization is going to be sp2. Okay, so sp2. This one is sp3, and this one is sp. Okay. If you order them based on hybridization, okay, the one with more S character, it will be the strongest acid. So number 1 is going to be the strongest acid, okay, and then you have number 3, and then number 2. So number 1 is the strongest acid, then number 3, and number 2, it will be the weakest acid, or technically the strongest base. So this one will be strongest. I mean, the conjugate base of it, it will be the strongest base. So I should just keep calling it weakest acid. So the weakest acid. Okay. Okay. So I covered all those factors: atom, resonance, induction, and orbital. And I hope that one helped you to figure out how to predict which one of those compounds is a stronger acid.